So now that you've had time to think about these questions, let's interpret that p-value. That p-value is the probability of getting a sample data at least as extreme as the one that we got, if in fact males and females had the same mean number of close friends in the population. So our p-value, that probability was 0.014. So it's pretty small. It's a little bit more than 1%, right? So the question is, do we reject the null hypothesis that the population means are equal at the 0.05 significance level? I would say because our p-value is less than the significance level, then we go ahead and reject that null hypothesis at that significance level. So the probability is so small, we're saying that we're pretty sure that that the means are different. Okay, is the observed difference in sample means significantly can't say this word, statistically significant at the alpha equals 0.01 level? So this is basically saying the same thing as L with a different alpha value. It's like two different ways to say the same thing. So since P is actually bigger than 0.01, it's not statistically significant at the 0.01 level. So we're going to fail to reject the null hypothesis at that level. So here's what we've got. When alpha equals 0.05, it's like we can say we are 95% confident that the means are different. When alpha equals 0.01, 1 minus 0.01 is 0.99. We can't say that we're 99% confident, right? So we're going to fail to reject the null hypothesis. I'm not 99% confident that the means are different. All right, so think about those technical conditions. Is this all valid? Yeah, because it was stated that it was a random sample. Also, our two sample sizes, N1 and N2, it was like, what was it? 654 and 813, both bigger than 30. So we don't even have to check to see if the data was normal. Our sample sizes were big enough, so all of this is valid, okay? Let's go ahead and create a 95% confidence interval. We'll do this once by hand, and then we'll go ahead and do it on our guru. So here's what we do. We take our two sample means and subtract them, right? That's going to be the difference. And then we'll add and subtract the critical value times the square root of the, the standard deviation squared over the first sample size plus second standard deviation squared over the second sample size. So for us, these are our numbers. So our two means are 1.861 and then minus 2.089. So that's our x1 bar minus x2 bar. This 1.965, that is a t-value that we get by looking at the table. Again, we're doing it once by hand, but we usually don't do this by hand because we have technology. So we're going to go ahead and look at this table. Okay, not the normal probabilities. Sorry, next page. The t-distribution. See at the top there, it has confidence level. It's like that second row. You're going to look at the 95% confidence level there, and then go all the way down to where the degrees of freedom is equal to 500, and then there is the value 1.965 is the t-star value in the table that corresponds to a 95% confidence level with degrees of freedom big, like 500. Okay, so that's our t-star value, and then we put in our s1 squared over n1 plus s2 squared over n2. Do that calculation, subtract and add it, and you get these two values. Those are the two endpoints of our confidence interval. So our 95% confidence interval is between negative 0.41 and negative 0.045. And here's what we have to think. What does that mean? First, we are 95% confident that the difference in the population means is between those two numbers, negative 0.41 and negative 0.045. And since it was the men minus the women, then the men should be smaller. So women tend to report more close friends. So thing you want to look for is 0 included in this interval? If 0 is included in the interval, then what you're saying is you're 95% confident that 0 could be in that interval, so that the means could be actually equal. But since 0 is not in that interval, this is actually good for us. We're 95% confident that the difference between the means is always negative, meaning that the number of close friends that men claim to have is always less than, or is usually on average, tends to be less than the number of close friends that females claim to have. So this is good. If our confidence interval contains the number 0, so it has negative and positive values, then we can't really say anything. We're not going to reject the null hypothesis because 0 could be there. The two means could be equal. But since our confidence interval does not contain 0, then we're saying, I'm 95% confident that the means are different. And in fact, the mean that men report is less than the mean for women. Okay. All right.